So I'll talk more specifically about the graphics view because that's the real core engine within Qt that allows us to create the complete framework. So I've taken an example from the Xgxperf toolkit that allows us to show a simple widget box with which displays a particular text that you are passing it as a parameter. The size is passed as a size and the location of the widget are passed as parameters here. So this is how you create a simple box. For example, this could be an application where you need to display the temperature of a particular motor on screen. So you can. This is similar to that example. So this is a rectangular widget, and this is the text that goes inside that widget box. So you create a new class, and you add that item to what is called as a graphics scene. So a graphics scene is the core component which is related to the graphics view. So the graphics view is like a canvas that you can it's like a large canvas, and in that canvas you can add all these items. So that's what it indicates. So you are adding one item into the canvas. You can add many more items and make them visible on the screen. And the advantage is the graphics view, it has additional properties like you can, when the graphics view itself scales, automatically the items which are placed inside that will also scale. So you don't need to manage individual items once you place inside the graphics view. So this is specific to, so once you add the item, obviously when you exit the application, you also need to remove it. So this is a placeholder, the work item, this is a placeholder where you're placing all the added items into that, so that the framework itself takes care of deleting them when you exit the application. So this is a very simple application that we are creating here, and you can try out using the toolkit that we have. So to summarize, so the simple application would probably have a widget which is created with a new which is a C++ template again, and you will add that item into a graphics scene. And you will have some more bookkeeping to do, namely deleting that when you are exiting the application. We'll see in more detail about what this, what the other items are, what is this init process and what is the other items. But this is a very simple summary. Okay, so let's move on to some more basics. So this slide is covering the widget process. So what Qwidget looks like. So if you look at things like date and edit components, these are all different classes that Qt offers. So QLabel, for example, is basically just a simple text. You can also add images to that. For example, if this is your typical desktop or a thin client application that you want to create, you can have multiple components inside that widget, and you can update them as you need. So this is a standard example provided by Qt itself. So we can we can search on the Qt web pages for each of these classes and what they do. But the overall layout is that there is you can see on the outline. So there is a parent widget, and inside that you will have various sub widgets which take the parent as the as the embedded component. So you can have multiple widgets inside a parent component. That's what this slide shows. You can have a picture here, you can have animating components inside a widget, and after you add all this, you can place any number of widgets within a graphics view. So moving a little bit further, the complete UI framework is based on widgets, and each widget, as we saw in the earlier slide, so they respond to various UI events. Going back to the previous slide, for example, if I click on this arrow, so there is an event handler within Qt that takes care of updating this particular portion of the screen. So there are various event handlers for the key process and mouse movements and click and scroll events. And each widget is responsible for updating its screen area. So for example, animations happen like this. Each widget also has a parent, as we discussed it. We can create complex shapes, not just rectangular. Over here we are all talking about rectangular shapes. You can also create a round or any arbitrary shape widget to make it look nice. There are classes, provided examples in this automation classes in the Xgxperf toolkit. So So most Qt classes are derived from QWidget. For example, QGL widget is the one which is derived. So by deriving, we are talking about specifically the C++ concept of inheritance. So most of the properties are inherited, and you can override some of those properties as well. For example, if you want to override or disable certain properties, you can give your own implementation without using Qt's implementation. So, typically this is how you create a new widget. So you'll, for example, a new Q push button, and you'll call some of its sub API, to do certain operations which are exposed by that class. For example, Q push button will have some classes like update or paint that you can search for. So in general, if you want to get on any Qt class, this is the way you look at it. So the doc.qt.nokia.com is the standard web link, and 4.6 is the Qt version, and QWidget is the name of the class. So if there is another class that you want to help on, you just replace it with another name. Okay, so looking at a little bit detail on the Q graphics view. So as I mentioned earlier, so this is the canvas for adding various graphics items. So the graphics view itself is it's a background widget. So you can replace that widget with more optimized, accelerated widgets. For example, if we have some optimizations using ARM, or algorithmic optimizations, we can replace that widget with other widgets to optimize to speed up the graphics view itself. So that's the viewport. So you can replace whatever Qt provides the regular Q widget with your own viewport widget. As we said earlier, so the graphics widget has a drawing canvas. For example, you can overlay one widget on top of another using its depth. So you can position various widgets. For example, if there are multiple widgets which you want to provide a nice iPhone-like effect or a clutter-based effect, you can provide depth to each widget so that it appears on top of each other. So all that is supported by Q graphics view. So and there are more advanced functionalities like blending and animations which are supported. So we'll look at that in the successive slides. So moving on further, so the signals and slots is one core component of Qt. This is the mechanism by which a callback mechanism can be implemented. This is similar to the signal slot. This is similar to what we have natively on C. For example, like function pointers. For example, in interrupt service routines or in a typical abstracted class, you provide a structure and a function pointer. So the advantage of using signal slot on top of it is it provides type checking, standard type checking as well. So rather than crashing somewhere in a critical application because the type did not match, the signal slot allows us to provide a standard type check mechanism. In fact, if the types don't match between the signal and slot, the mechanism itself won't work. So there are other functionalities also for the signal slot. So I'll, for details, you can refer to the standard documentation. So the example use cases will be, for example, if there is a blocking thread, if you are waiting on an event, for example, a networking event or input event from a user, or probably something that takes a lot of time to load. For example, a web browser on a low bandwidth network connection user interface till the event is complete. We can provide a non-blocking event handler and provide it as and have a callback function in a slot. So how do we communicate those events? So we have the signal slot mechanism for the event completion. So again, in the Xgxperf toolkit, you can look at the browser lib as an example. So it implements, for example, a large complex web page rather than waiting for it to load and hanging the UI. So you can allow the browser to load the page in the background and have the UI still functional. So how does it work? So the next slide shows the real implementation. So typically in your class, this is how you will implement a signal and a slot. So this is your implementation of some inherited class. The first thing that you would notice is you need to have this Q object, specified here. This is how this is the mandatory thing for Qt's Meta Object Compiler, that's a MOC concept, which basically allows Qt to maintain a standard internal database of various objects so that the signal slot mechanism can work. So this is very much needed for the Qt's Meta Object Compiler to work. So then you can have all your other implementations. Now, all the signals that you want to emit or the slots that you want to handle. So there is a keyword called signals, and in the signal you will define the signal that you are going to emit, and you can in that case of in this case we are only talking about the signal. So there will be a corresponding another class or another thread which will handle the slots. So you will define slots and the corresponding function here. So this is how you emit the signal. So you will there's a keyword called emit and the corresponding signal that you have already mentioned here. So in the slot, in the corresponding slot, you will also have a similar definition, declaration, and you will be implementing that in probably in the same file or in another file. So you can see that there's a main widget function. So to connect both, so there's an API called connect, which has this prototype. So you have the this is the first parameter. The first two parameter refers to the signal and the corresponding thread, and the next two parameter talk about the slot. The third parameter talks about the class which contains the definition of the slot, and the next one is the function that implements the slot. So there are four parameters. The first two talk about the signal itself, and the second two talk about the slot. So when you do a connect, so these two are connect, corresponding slot function will be called. So you can check it out by actually doing a printf or using your own favorite debugger. But this is a standard mechanism for working across threads and providing type checking in the case of Qt. This is a very important concept, and that means that you can see across all implementations and examples in Qt. So one classic, further example that I can provide is, for example, if there is a timer that timer interrupt that you want to handle, so you can use the signal slot mechanism for the timer and its event handler. So again, so in the case of Xgxperf, we have several examples of this, and also Qt also provides its own example. So you can take a look at that. Okay, so we'll quickly look at another key component called QPainter. So the QPainter class is the fundamental drawing module which does pretty much all the rendering and drawing modules, drawing operations within Qt. So this is the lowest level drawing API. So this is, all the widget operations ultimately go through this. So you can find many of the operations in QPainter which are not exposed outside. So if you want to perform any specific operation, this is how you handle. So for example, if a particular widget API does not handle, for example, the mask operation that we talked about earlier, or if you want to add a fixed map or any bitmap to a widget, the simplest way to do it is you can override the paint event of the widget, and you can use the QPainter object for that particular widget within the paint event handler and do the various operations exposed by QPainter. Again, so there are examples which are available in the toolkit that you can take a look at. So this is again a very important concept. So because QPainter is not exposed normally outside, so you need to override that and do its operations within the QPaint event. So the paint event is a standard handler for all the painting operations. By painting operations, this means any kind of widget update. For example, when you move a particular window from one region to another, or when you resize, or any kind of painting or update operation, it ultimately comes down to this paint event. So you can override that operation or modify that operation with your own implementation.